All right, guys, we'll go ahead and jump on in where we left off. We finished virtual wire pairing, and we're going to go ahead and jump right into software switching on the FortiGate. All right. So, what is a software switch on the FortiGate? All right. So, software switch, it groups multiple interfaces to form a virtual switch, aka a VLAN. Right. But it's not so much a VLAN, it's actual virtual switch, right? Which acts as a layer 2 traditional switch, right? This means that all switch interfaces are part of the same broadcast domain, aka a VLAN, right? See what I did there? So it's not actual VLAN, but it is a VLAN if you think about it. So uh, that's typically what a software switch is if you create it within the GUI of the FortiGate, right? Real simple to go ahead and configure, right? You go ahead and go to the network interface, then the interfaces section, right? Go ahead and click on new interface, right? Give it a name, an alias. The most important part is, of course, you go to type and you select software switch, okay? One thing to note, right? Just like a regular switch, right? If you assign this an IP address, okay, all the ports that are assigned to that software switch, they share that IP address for the software switch, okay? With the software switch, you do have to configure firewall policies and you configure routing just for it, okay? All right, let's move on. Okay, so let's look at this example real quick, right? So, right, we have our admin, right? They went ahead and we're gonna call our admin Don, right? And we went ahead, right, and we have port 1 and port 2 and our wireless interface, right? All in the same interface, which is of course the software switch, right? What does that mean, right? They're part of the same broadcast domain. Okay. Right. And so, right, they're part of the same 192.168.1.0/24 network. Okay. So, what does this mean? That means a PC, right, that's hanging off of port 1 can reach a printer that's hanging off of port 2 or a wireless device that's hanging off the wireless interface. Okay. So, go ahead and just keep that in mind, right? It's really, it's if you learned about layer 2 from our routing and switching section, it's basically that. Okay, it's really not that bad. All right, let's go ahead and keep going. All right, now one thing quick to note, right, is that again, what you guys are creating essentially is whenever you create the software switch is a broadcast domain, right? So you're inserting a switch basically into your Fortigate. That's exactly what you're doing. So just try to remember that for the exam. And so just try to keep that in mind. Besides that, that's all you need to know for a software switch. Okay. All right, let's get a little quiz going. Right. So just for our knowledge check, question 1. Right. In which operating mode is the software switch function supported? Is it A, transparent mode, or is it B, NAT mode?
B, NAT.
There we go. There we go. All right. Question 2. Which interface can be a member of a software switch? Is it a VLAN interface or is it B, a wireless interface?
Is it B, a VLAN? I mean, a VLAN interface? Okay, never mind. B, wireless.
Yep, it's a wireless interface. Remember, VLAN interface is already its own broadcast domain. So why would you put
right,
exactly. Okay. All right, let's keep rolling. One of my favorite topics, spanning tree protocols. Man, love this. So first, let's talk about the why, right? Why do we need spanning tree, right? So before spanning tree existed, right, we went ahead and, people would connect switches, they would try to extend networks, right, and have redundant connections, right? And you can do that, you can plug everything in, right? But with redundancy comes issues, right? What'll happen is, right, let me go ahead and get my favorite pencil, right? This PC will go ahead and say, hey, I want to go ahead and send something to this PC, right? Before spanning tree, right? Right? This switch that receives the traffic is going to send it everywhere, right? But one of the rules that you guys learned about layer 2 switching in our routing and switching section is that one of the 3 major rules of a switch is to forward frames, right? So imagine without spanning tree, right? Donovan's trying to reach my Kivia. Without spanning tree, without one way of traffic to go to, right? Traffic is just going to keep going in a loop because they're going to do its primary job, which is forwarding frames, right? Without that role of loop prevention, is going to continuously attempt to just send frames and send frames and send frames. And what do we have? We have a broadcast storm. Okay? And the broadcast storm is not good because the network is going to be held up. Switches are probably going to stall and nothing is reachable. Okay? So keep that in mind, right? When you're trying to understand spanning tree. All right, so let's go ahead and talk about with spanning tree being implemented, right? So we talked about the broadcast storm, right? Now we have the technology spanning tree, right? So what does spanning tree do, right? High level overview, right? What spanning tree does, right? They go ahead and communicate. They make switches communicate with each other, right? They have a talk, right? And they say, hey, can I go ahead and do X, Y, and Z, right? Can I go ahead and be the root, or can I do this, that, and the third, right? The overall goal is to elect one switch to serve as the root bridge. This is very important, right? That root bridge is it's like the police officer in a in a traffic section that's directing traffic, right? That's what the root bridge is. It's a root switch, right? And what happens is once that root bridge is elected, right, that is the king of the broadcast domain, right? And so what will happen is now they communicated and said who the switch is, right? Who the root switch is. What will happen is switches will then start sending BPDUs, right? Bridge protocol data units between each other, right? And they'll start communicating. They'll say, hey, what's your data look like? What's your data look like, right? And it's going to, they're going to go ahead and provide the information about themselves, and about the route, right? And they're going to make decisions of how traffic should flow, right? They're going to do a spanning tree algorithm, right? To go ahead and calculate what is the best path, okay? Once all the paths are known, right? And what the switches are going to do is going to go ahead and say, hey, we need to identify if there's any loops in our network, right? And designate who's going to be the root port, right? And based on the lowest forwarding costs, right? Right? Who's going to be like for that root port, who's going to be my root port based on having that lowest cost, right? All the other ports, right, that may cause a loop, it's either it's going to be a designated port or I'm going to block it. Okay? Right?
No, I got a question.
Okay.
So when you say designated port, you meaning like designated for incoming or outgoing traffic?
That's one way to look at it.
Okay.
That's one way to look at it. But it all depends on segments, right? Right? It all depends on segments. So let me go ahead and get my pencil, right? So if this switch and this switch is talking to each other, right? This is the root port, right? And let's say this is the topology. It's just a quick triangle right here, right? This is the root port, right? Right? This is the designated port, right? Because we need to go ahead and designate a port to send traffic to the root, right? But what do we have here? We have a potential loop right here, right? So what's going to happen, right, is they're going to go ahead and communicate with each other and say, hey, what's what's your path to the root looks like? Oh, what's your path to the root looks like, right? They're going to go through a series of elections, tiebreakers, and once we have a winner, right, we're going to say the winner is going to go ahead and get blocked, right? And this is going to be a designated port. So we still have redundancy, right? We still have redundancy. Redundancy is there, right? But what happens is if something happens, right? Maybe, we're not able to reach the root through this port, right? We can go ahead, and what spanning tree would do is, again, these BPDUs that are sent every 2 to 3 seconds, right, to each other, they say, hey, I can't reach the root. Can I go through you? Spanning tree it has the technology to automatically change its topology to pass traffic another way, right? And to unblock a port. That's why the BPDUs are so important within layer 2 switching.
I have a question, David. So the
Okay.
strength protocol, that's configured on the management switch or the root switch? Is that fair?
Say it again.
So spanning tree protocol, that's configured on the management switch or the root switch?
Spanning tree is configured on every layer 2 switch.
Okay.
Yep, every layer 2 switch, right?
So how do you know which switch to designate to have the designated port on?
Like if you were breaking up, is this just me, Don, or was she breaking up?
Oh, hello, can you hear me?
Yeah, she was breaking up a bit.
Oh,
Okay.
I was asking, can you hear me now?
Yeah, I can hear you.
Okay, I was asking, how do you know which switch to configure the designated port on?
Yeah, that's a good question.
If you're configuring all STP on all the switches.
That's a good question. So that's more so a design question for whoever's setting up the network, right? So you can configure any switch to be the root switch, right? It's all based on your design.
Oh, okay, so it's just
Okay.
on the architecture texture.
Yep.
Okay.
Yep. Now, if you go back to our, whenever we had our routing and switching series, we did go over it. But brief overview, right? The switch with the lowest, right?
Oh, the lowest cost?
The lowest BPDU.
Oh, BDP. Okay.
Right? Bridge protocol data unit, right? Is going to become the root, right? Now, let's break this out a little bit. There are several ways a switch can go ahead and become you can influence a switch to become the root, right? You can change the priority. Okay, you can't change a MAC address, right? But you can change the priority, right? And influence some other things so that it can go ahead and become the root. So just go look back at those videos, right? And routing and switching, it'll definitely make sense.
Okay.
Okay.
Okay, I got
All right.
one more question.
Okay, sure.
Now, in the event one of the switches go down, would it still route the traffic the same, or it just would just mess everything up?
What do you mean the same? Because automatically, if there's one path that's active and that path goes down, then of course the path is going to change.
Okay, so like if I just get a dead switch, it's just, even though that switch is dead, it's still gonna. Okay, I get what you're saying. Never mind. I get what you're saying. As I was saying it, I kind of like realized what I was saying. So.
I mean, are you wait, hold on, because I want to make sure. Like, so are you saying? So Don, are you saying like switches in production and that switch is the root switch? Is that what you're saying?
Yeah, and it just break. Like something goes on the switch, and the switch is just not working anymore.
Oh,
Would
okay.
the other switches still, like, would the protocol still work the same?
100%. 100%. If you do a packet capture on a switch, right? BPDUs are sent. I mean, seconds, milliseconds. Okay. So if any type of topology change happens, right? The first things first, right? And I don't want to get too deep into switching because that's its own dedicated. I can talk for hours on that, right? But what's going to happen is the language that switches speak to each other, which is BPDUs, are going to notice a topology change, right? And so that topology change is going to be, this is talking from a high level, that topology change is going to be communicated to all the active hosts, which are switches, within, in this context, within the spanning tree, right? They're going to hear about it. They're going to realize, hey, this host is down, right? They're going to communicate so quick to the point to where, you know, where you're going to see failover happen to another path, right? The great thing about BPDUs and spanning trees is that they are able to detect outages, okay? They're able to understand, hey, this path isn't working. We need to choose a new route bridge. We need to unblock ports, and we need to go ahead and go through an alternate path.
Okay. Gotcha.
Okay.
Yep.
All right. With all this being said, okay, here's the trippy part. Fortigate, right? It does not participate in spanning tree by default. I need you guys to remember that. So you can configure a software switch, right? Configure certain ports to be in that software switch. You connect the switch, an actual physical switch to it by default. Those ports off the FortiGate that's now a software switch do not participate in STP. They don't send BPDUs or anything, right? You have the administrator are going to have to enable it. Okay? Okay?
Yep.
All right. So I need you guys to remember that, and that's definitely going to be on the exam. Okay. So of course, if you guys, once you configure, right, your software switch, if you want to go ahead, right, you want this software switch to participate, right, in spanning tree, absolutely can, right? And of course, I would recommend, right, you guys, if you're deploying a FortiGate and you want to have a software switch, right, please enable spanning tree, right? What this means, of course, you'll have to set the forward delay, hello time, max age, right? Set, of course, the priority, which is important for root bridge elections and other things. You have to set the, of course, to configure config provision number, of course, for like BTP, VLAN, chunking protocol and stuff like that. So make sure that you understand you have to go into the CLI to configure this, okay? And that's it. That's it. Not too bad. But again, this config system STP, this only can be done at the CLI to configure spanning tree. Okay. All right. So, so real important thing here, right? And this is for forwarding BPDUs, right? They, of course, Fortinet, I don't blame them for naming it weird, but spanning tree forwarding, right? Or BPDUs, right? BPDU forwarding, right? It's basically, right, for interfaces that are not physical switch interfaces, right? You can either forward or block spanning tree BPDs, right? So you can set the actual interface and say, hey, are we going to enable BPDUs to be received on this interface or be transmitted from this interface? Or do we want to go ahead and disable it? You do have the option to do that. You could, right? And what does that mean, right? Globally, you can go ahead and enable, right? At a global level, enable spanning tree, right? But then you can go at the interface level and say, I don't want to participate in sending BPDUs, right? You can do that from a design standpoint. And there may be a reason why you have to do it. Just know you have this available to you. Okay? All right. With that being said, right? Let's go ahead and go have our end of section review, right? What is the default mode for spanning tree on a FortiGate? Is it A, FortiGate passively forwards BPDUs, or is it B, a FortiGate has all spanning tree functions disabled?
B, disabled.
There we go. All right. Last but not least, we got best practices for layer 2 switching. Okay. And it should be real quick, right? Fortinet does a good job giving you guys recommendations, but again, they aren't, their company wasn't built, and forgive me, Fortinet, they weren't started based off of routing and switching. Okay. They are a security company, right? So they're going to give you high level things, right? Like these 5 things right here, which is useful, it's helpful, but I'm going to recommend you, right, is to go back and look at our routing and switching section. Okay. All right. And this is very, very important. Very, very important. Okay. Please go back in our routing and switching section because again, it will all make sense whenever you start reviewing again the infrastructure and the security section for this exam. Okay. But for the sake of this, and if you guys go back on the recording, I'm going to name off these best practices from Fortinet, right? Of course, create broadcast domains. I'm not going to call it forwarding domains. Create broadcast domains when VLANs are used and set VLAN forward to disable, right, on all relevant physical interfaces. Okay. The broadcast domain ID can be different from the VLAN ID. Okay, but it is recommended for troubleshooting and readability to keep them the same. Okay, when using broadcast domains, right? We'll use forwarding domains. When using forwarding domains, it's the same thing. A router is required to move traffic between the forwarding domains. Okay, this is very, very high level from Fortinet. Okay, please just keep this in mind, but still lock it in so you can pass the exam. Okay, only interfaces from the same forwarding domains can have firewall policies between each other. Okay, all right, because spanning tree BPDUs are not forwarded by default, use caution when inserting Fortigate or any other forwarding device or layer 2 device, because this can break the spanning tree and lead to layer 2 loops. Because again, BPDUs and spanning tree is not enabled by default. Make sense?
Yep.
But again, guys, please, if you want to know way more about routing and switching, and especially layer 2, please go back on those videos and look at other people who've covered the topic of layer 2 routing and switching. Look into some CCNA stuff from Cisco, and it'll help you out tons. Okay. All right. With that being said, you guys are done with the layer 2 section. Okay. The next section will be IPsec. We will be taking our time with that one because unfortunately they will be going into detail on the exam for that one. So we will have to do some labs. We'll probably have to repeat some labs. So make sure you do a little pre-reading on IPsec. Bring all your questions. Ask any questions, and I'll see you guys next time.
Right,
Alrighty.
sounds good, guys. Bye.
All right, guys. Later.